2, well, at least when I taught algebra 2, I always spent one day with long division and then one day with synthetic division. And for me, I truly like synthetic division better. It's quicker, it's faster, but sometimes long division is necessary if it doesn't fit the form for synthetic division, or sometimes long division might be the better route. So just a little reminder here, if you're going to long divide with polynomials, you can't skip any exponents, right? So like it has to go from the highest degree down by 1, so 3, 2, 1, 0. This is what you're dividing by, so it goes out here, 3x minus 2. I'm going to make our big division thing here. The biggest mistake that happens with long division is just it's easy to mess up a negative, or it's easy to make a silly arithmetic error. On the test, I'm going to give you one question that I ask you to long divide. You could always check it with synthetic division and check to make sure the answer fits if you like synthetic division better, but I think it's a good skill to know how to long divide. And remember, it's just like long dividing with numbers, it's just letters in there. So I always say, look at this, and you say, what do I multiply 3x by to get 6x cubed? Well, 3 times 2 gives me 6, and I need an x squared times x to give me x to the third, right? So you really don't need to look at the second term, you just look at the first term and the first term here. And just like with regular numbers, we're going to take this and multiply it by the whole thing and line it up. That's why it's important that your exponents go down by 1. So if I multiply that, I should get 6x cubed. And then 2x squared times negative 2 is negative 4x squared. What's happening over there? And then remember with division, you subtract, right? So it's up to you on how you want to do this. For me, when I subtract everything, because otherwise I'm going to mess up my sign. So for me, I'm going to change colors here. I always say subtract, and if I'm subtracting a negative 4, I'm going to change that to a positive 4. So then that way the signs are exactly what I need. Some people don't like that. Like, as long as you're doing it correctly, I don't care. But I just know the number one mistake that happens here is people mess up their signs. So I go through and I change the sign of everything, and every time this should cancel out, and then you just do the math. Negative 16 x squared plus 4x squared is negative 12x squared. And then you bring down the next number, right? Just like long division from 3rd grade. But we haven't done long division from 3rd grade in a long time. And you repeat the process. You go back and you say, what do I multiply 3x by to get negative 12x squared? And what would the answer be? What do I multiply 3x by to get negative 12x squared? Negative 4x, because 3 times negative 4 gives me negative 12, and x times x gives me x squared. But you also have to take that times the negative 2. So negative 2 times negative 4x is positive 8x. And again, remember you're subtracting. So for me, I'm going to say subtracting is going to change that to a plus sign, and that's going to be subtracting again. That should cancel out. And 17x minus 8x is 9x. Bring down the last number, minus 6. And 3, right? I just need a 3. So 3 times 3x is 9x. 3 times negative 2 is negative 6. So that works out so nicely that when I subtract, then I get a remainder of 0. So what is the answer? And your book kind of uses some weird wording, like write it. I'm not a big stickler for the notation, but just in case you want to do it the way they say to do it. It says, write a summary statement in polynomial form and fraction form. I think that's a little unnecessary, but polynomial form means they want you to realize that if you take this times this, you get back what you started with, right? That's what division is. If I took 3 and I divided it into 21, I get 7. Why does that work? Because when I take 7 times 3, I get 21, right? So if you're checking the back of the book, just so you know, the polynomial statement would say 3x minus 2 times 2x squared minus 4x plus 3, because if you multiply that together, you get back the polynomial. When I ask you to long divide, I'm just looking for the answer. So I'm okay if you don't write it in the polynomial statement. But it's kind of a good connection, like so you can see that that is what you get if you FOILed that out. If you distributed, you would get back what you started with. So I just make reference of it just because the book talks about it. We better do this one too. So once you learn synthetic division, you think, why would I ever do long division again? Well, one, if there's a coefficient in front of the x term, you have to like kind of make an ugly fraction sometimes to do synthetic division. But here's an example where synthetic division is not an option. Is what you're dividing by is not a binomial. You have to do long division. All right, so this is an example of a long division problem. So the top number, right, that's what's going to go under here. And remember, this is a good example of filling in your zeros. So you'd have plus 0x cubed plus 3x squared plus 0x plus 1. If you don't fill your zeros in, it's not going to match up, and then bad things will happen. So on the bottom is what I'm dividing by, so that goes down here, x squared minus 2x plus 3. This looks really awful, but it actually goes by really quick because there's 3 terms, so you're going to see that we get our answer really quickly here. Anyone have a question? We're just looking at this one and this one. So what am I going to write up here? What times x squared gives me x to the 4th? X squared. But I have to multiply that by this whole thing, which means I'm going to fill in 3 spots already. So this is going to actually be shorter than the last one. So I'm going to get x to the 4th minus 2x to the 3rd plus 3x squared. Again, watch your signs here. So I like to go through and do this. So 0 minus negative 2 is just 2x cubed. And 3x squared minus 3x squared is actually 0x squared. And we're still going to bring down our next number, which is 0x. Do it again. So I need a 2. And to go from x squared to x cubed, I need an x. So that would be 2x cubed minus 4x squared plus 6x. With me on that? So I get 4x squared minus 6x plus 1. Notice how easy it is to just mess up a negative sign somewhere. So that's why when I grade this, I just have to kind of look through it and see what happens if you didn't get the right answer. But last step, what do I multiply x squared by to get 4x squared? I just need a 4. And I get 4x squared minus 8x plus 12. So I think I get 2x minus 11 left. Remember way back in the day of elementary school, like when you first did long division, you put a little r out there for remainder, which really just means nothing. But hopefully at some point you learned that what's left is just like you take it and you make it a fraction over what's you divided by, right? So like if you took 4 divided by 18, you can say, oh, that goes in there 4 times with 2 left over. You don't put R2. You say that's 4 and 2/4, because 2 over 4, or that's 4 and 1/2, right? So your remainder is like the fractional amount left, We do the same thing with polynomials. So to write the remainder here, we're going to take what was left and divide it by what we divided by, which is x squared minus 2x plus 3. So when there's a remainder, it's kind of a really ugly answer, but this whole thing is your answer. So you can't just drop that remainder off when you're long dividing. Memories of this from most of the time, it seems like what we're dividing by is a nice binomial, so that's where synthetic division is very nice. Very quick, usually not as much mistakes, and definitely not as much work to do synthetic division, but you have to just kind of remember how to do synthetic division. I always remember synthetic means fake, right? Synthetic fabric is not natural fabric. It kind of takes the rules of division and breaks it up a little bit. So a couple things to remember with the synthetic division. One, what you're dividing by is always x minus r. So you always take the opposite sign of what you're dividing by. Or if you think about it, you're dividing out the 0. It makes sense that if the factor is x plus 3, the 0 is negative 3. And then, I don't know if Mr. Oswald taught you this same way, but I always put what I'm dividing by up here in kind of like an upside down division box. And then I take my coefficients, again, filling in your zeros. So the coefficient of x to the 4th is just 1. I don't have an x to the 3rd, so I'm going to fill in a 0, negative 10, negative 2, and then 4. So you take the number you're dividing by, you take the leading coefficients, and because we've changed the sign here, the other reason that people don't make as many mistakes is now with synthetic division we get to add instead of subtract. And we're basically taking all the x's out to do the math, and then we'll put the x's back in at the beginning. And so you just have to kind of remind yourself of the steps here. Step 1, you bring down that first number. Then you multiply it up and you fill it in, and you just repeat the steps. So if you can get that first step started, you should be good to go. 1 times negative 3 is negative 3, and now I'm adding, and every time I get a new number down here, I just multiply it up, and I fill it in. So that would be negative 1. Negative 1 times negative 3 is 3. That would be 1. Negative 3. That would be 1. And for me, I always put that last number in a little box as well, because that is my remainder. So this takes up a lot less room and a lot less room for error in this, but you have to remember, this is just like the in-between work. You have to go back and put your x's in. So remember that when you divide, it's like you're dividing out one of the x's. So you always start with 1 less than the degree that was up there. So this was x to the 4th. So I can go down here and I can write my answer is 1x to the 3rd, and I'm just going to count down. Minus 3x squared minus 1x plus 1 plus my remainder, which is 1 over what I divided by, which is x plus 3. Remember doing synthetic division? Very helpful when we're finding zeros here. So I wanted to start with just reviewing that. What's really great is we have these theorems that save us from even having to do this every time. The remainder and the factor theorem. So let's look at the next ones here so we can talk about kind of why we're doing all this division, not just to keep it busy. So the remainder and factor theorem kind of go together. They're two separate theorems, but they're kind of always joined together. It says if a polynomial is divided by some factor x minus k, then the remainder is, oh, I thought I had some magic. There's no magic. Oh. Magic, yeah, there it is. No magic if I don't remember where to push. The remainder is f of k. What does that mean? It means that you don't have to synthetically divide if you're just trying to figure out what the remainder is. The remainder is what you get if you plug in k into that function, and we'll do an example of that in just a minute. But on the last one, if I wanted to show you what that means, If I wanted to know what the remainder was, I could just plug in -3 into that problem. So if I took -3 to the fourth minus 10 times -3 squared minus 2 times -3 plus 4. So instead of doing the synthetic division, if you just plug in that number into the function, what you get will always be your remainder. So if you're just looking for remainders, maybe, especially with the calculator, this is a faster way to do it than doing synthetic division. Why does it go with the factor theorem? Because if your polynomial has a factor of x minus k, the remainder has to be 0. So it says, remember this from geometry, this means if and only if. It's actually real math lingo, IFS, stands for if and only if. So a polynomial f of x has a factor of x minus k if and only if, when you plug k in there, you get 0. Meaning, if the remainder is 0, then it is a factor, which should make sense. If the remainder is 0, that means it is a factor of the function. Which means you don't have to do so much division on these. When you have to do division, when we start finding like what's left over, what are the rest of the factors, that's when you really have to do the synthetic division to find out what's left. But if you're just saying, is it a factor? You're just seeing if when you plug it in, you get a remainder of 0. So let's do a couple examples here. And directions like this are exactly on your homework. It says use the remainder theorem to find the remainder when f of x is divided by x minus k. So it's just practicing showing that you don't have to do synthetic division. So they're telling you if k equals 2, find the remainder. We could synthetically divide it or long divide it, but the remainder theorem is telling us that they don't want us to do that. They want you to realize all you have to do is plug 2 into that problem, and the answer that you get would be its remainder. They're not telling you that it's a factor, so it might be 0, it might not be 0. They're just wanting you to know remainder theorem means plug in the number. And you have a calculator, or probably you could get a calculator. This one's not so bad, I think I can do without a calculator. 4 times 2 is 8, minus 6 plus 1, 3. So what would the remainder be if I divided by x minus 2? The remainder would be 3. Some important things to point out. They're giving you the k value already, right? So you're plugging in that exact number. If it said x minus 2, then that's when you take the opposite. So you take the opposite if it's written as a factor, but if it's already solved for k, you plug that exactly in there. So if I ask you for k equals 1 here, all I got to do is plug 1 in there, and 1 minus 5 is -4. It doesn't ask this, but looking at that, I know that 2 and 1 are not zeros of those functions because the remainder wasn't 0. So we really only go one more step today, and then tomorrow we'll actually look at finding zeros and seeing what's left, and that'll be our last thing that we do before a test. But the only other thing really I'm asking you to do today is determine, is it a factor, which just means, do you get a remainder of 0? And again, really important that you know what number you're plugging in here. Could you just divide it out and see if you get a remainder of 0? Yes. Or you can just plug in what? Are you going to plug in 3 or -3 into this if you're using the remainder theorem? -3. So you can plug in -3 and see what you get. For me, sometimes if I don't have a calculator, I can do synthetic division just as fast as I can do the other way. Right, so you can plug that in, or you could do this also. I'm going to show you both ways. Do you get 6 when you plug that in? So you can just plug it in and you should get 6. Without a calculator, I did much better doing synthetic division because it was smaller numbers than working all that out and adding it up. But either way, because that doesn't equal 0, we can say that it's not a factor. Say no. Same thing on the second one here. We could just plug in positive 3 here. Or we can synthetically divide it. And you should get 0 on that one. And hopefully you have some memories of second semester Algebra 2 last year where you did this a lot. You had to guess a lot of numbers, and anytime you got 0, then you knew it was a 0. Like, that's where we're going with this. We're just kind of reviewing it all a little bit at a time, which means, yes, it is a factor. Questions about that? Okay, the last example there is kind of like the one we did the other day that I told you for sure you're going to see one like the test. I kind of just threw in some extra stuff there. Again, on the test, I'm going to want you to write that out in standard form, which means multiply it out. But it just says find the polynomial function with a leading coefficient of 2 that has degree 3 and has zeros at -1, 3, and -5. So, extra part that's different than the one we did last week is it says a leading coefficient of 2. Again, it's just kind of working backwards. So if they give you the zeros, I want you to go back and give me the factors, right? So you just think about that you would just add it over, right? That would just be x plus 1. That would be x minus 3 and x plus 5. What would I need to do to get a leading coefficient of 2 in there? In there. So if I do it in there, do I leave it as 2x plus 1? If I put it in there, now that would give me a 0 of -1/2, right? So if you put it in there, what would you have to change this to? If I change that to a 2, would that still give me a -1? That would work. It also would work if I just put a 2 out front. That would work too. It would work out the same way to do that. So just kind of a little extra thinking there. Remember, if I want you to give me a function, I want you to say f of x. And I want you to work it out and give me the polynomial function. Again, just kind of practicing, reminding you of this good old algebra that you know how to do. What would that be? -6 plus 2 minus 4x. There's a lot of multiplying, combining like terms there. And again, telling you for sure that there's a question like that on your test. So hopefully practicing it a few times, you'll be good to go on that one. Okay? So, 2-4 day 1 homework today. Did I ever give you an assignment sheet for this chapter? I don't think I did I? I'll work. Even though the test. Here, I'm going to double pages in case you're still ready to go. So, 3 through 30 multiples of 3 and 60, honestly, not a bad homework. There's a couple with some division that Wendy will talk about tomorrow, but hopefully a nice homework tonight that you'll be able to do. And then tomorrow we'll add one extra thing, solving these, and then that'll be all the new information before we have our next test later this week. Make sure if you're behind on homework that you get caught up, because remember that all of your homework for chapter 2 will be due on the day of the test. And the end of the 9 weeks is quickly approaching. I believe next Friday is the end of the 9 weeks. So it'd be really nice if we could get our test in and I could get it back to you, and then you can get it retaken if we did before the end of the 9 weeks.